So my name is Ayodeji Felix Isariade. So I want to use this medium to welcome you most sincerely to my channel. So if you are a science student or a mathematics student or an engineering student, if you're a graduate student or an undergraduate student, this channel is the best for you. So I want to implore you to use just a minute of your time to click on the subscribe button, and then don't forget to also turn on your notification for more updates. So today we'll be looking at differential equations. Differential equations. So let's begin. Recall that if y equals a x raised to power n, the derivative of this, which is the y, the x, will be n times x raised to power n minus 1. So therefore, if y equals 3x raised to power 3 plus 4x squared plus 2x plus 3, then the y, the x, will give us 9x squared plus 8x plus 2. So let's call this equation 1, and let's call this equation 2. So from here, we'll be bringing out two different variables. We have dependent variable and we have an independent variable. So here, y is called the dependent variable. Y x is known as an independent variable. So a dependent variable in a mathematical equation or statement is a variable that depends on another variable. So why an independent variable is a variable that doesn't depend on any variable. So for example, if we have let's say we have y equals 6x squared plus 3x plus 2. So here, this y is called dependent variable. And x is known as independent variable. Also, if you have z equals, let's say 2x plus 3y plus 4. Here, this is our dependent variable. Y, both x and y are called independent variable. So we'll be defining some terminologies as we proceed. So let's quickly define what a differential equation is. Definition. A differential equation is an equation that contains one or more dependent variable. That contains one or more dependent variables with respect to one or more independent variable. So here, there should be derivative here. The differential equation is an equation that contains the derivative of one or more dependent variables with respect to one or more independent variable. So if you look at this equation 2 is a derivative of equation 1. So therefore, the y dx equals 9x squared plus 8x plus 2 is an example of a differential equation. So when we're talking about differential equation also, we have three major classifications of differential equations. So let's quickly look at that. Classifications of differential equations. That is, a differential equation can be classified by 1. Classification by types. 2. Classification by order. Then 3. Classification by linearity. So we'll be taking this one after the other. So let's quickly look at classification by types. Classification by types. Okay, we have ordinary differential equation, which is known as ODE. So an ordinary differential equation is an equation that contains the derivative of one or more dependent variable with respect to a single independent variable. This is an equation so let's just use, this is an equation that contains the derivative of one or more dependent variable with respect to a single independent variable. So you have to underline the word single. So for a differential equation to be ordinary, it must have a single independent variable. For example, the y, the x is equals to 2x plus 3. This is example 1. 2. Let's say the square y over the x squared plus 3 the y, the x, plus 4x equals 0. These are called ordinary differential equations because we have just a single independent variable x. So that is that about ODE. Now, by type, we also have what we call PDE, partial differential equation. PDEs, partial differential equations. So partial differential equations are equations that contains the partial derivative of one or more dependent variable with respect to two or more independent variables. So these are equations that contains or that contain one or more dependent variable with respect to two or more independent variables. That contains partial derivative of one or more dependent variable with respect to two or more independent variables. So for example, if you have the square u the x plus the u the y plus 2xy equals to 0. So here we have just a single dependent variable and we are having two independent variables. So these two independent variables are what made this particular equation to be a partial differential equation. So also let's talk about classification by order. Classification by order. Classification by order. So the order a differential equation is the order of the highest derivative. Is the order of the highest derivative or differential coefficient. So for example, if you have the square y, the x squared, or let's start with one other, plus 3x plus 4 equals to 0. And also we also have, let's say we have the square y, the x squared, plus the y, the x, plus 3x equals 0. And also we have the q y, the x cube, plus 4 the square y, the x squared, plus 3 the y, the x, plus 4x y equals 0. So let's stop here. Now, how do you determine an order of a differential equation? The first thing you have to do is to look at here. It says the order of a differential equation is the order of the highest derivative. So the highest derivative here is 1. So this particular equation is a differential equation of order 1, or you say first order. So when you look at this second differential equation, you will notice that this is of order 2. We are having 2 here because this is greater than what we are having here. So therefore, this is of order 2, or you say second order. So let me give you just 10 seconds to tell me the order of it. Great. So this is of order 3 because this is the highest derivative. Order 3 or third order. So that is that about classification by order. So let's look at classification. Also, before I leave here, we also have what we call degree. So the degree of a differential equation, the degree of a differential equation is the power of which the highest derivative of which the highest derivative is raised. For example, we have the cube y, the x cube, plus 2 the square y, the x squared, let's say this is power 3, plus the y, the x, is equals to 0. So to determine the degree of this differential equation, you have to first of all identify the highest derivative. This is the highest derivative, which is the cube y, the x cube, followed by the square y, the x cube. Because this is the highest derivative here, your order, or the degree rather, of this differential equation is 1. So here, this is of degree 1, the degree is 1, y the order is of order 3. So let us give one more example. One more example. Then we move to differential classification by linearity. So the second example, let's say this is, let's say we have 3x, the square y, the x squared, raised to power 3, plus 2xy is equals to 0. Or let's say we have the y, the x. Let's say we have 2x this, then plus 3 is equals to 0. So we have to determine the degree and the order of this particular equation. To determine the degree, you have to first of all identify the highest derivative. Here, this is the highest derivative. Then you have to look at the power. So the power of this highest derivative will be your degree. So in this case, this equation is of degree 3 or third degree, while it is of order 2 or second order. So let's quickly look at classification by linearity. So it is important for us to set this background for better understanding of the topic. So classification by linearity. A differential equation is said to be linear is said to be linear if the degree is if the degree is 1. If the degree is 1 on the dependent variable and its derivative. So for you to say that an equation, or for you to say that a differential equation is linear, it must be of first degree on the dependent variable and its derivative. For example, we have the y, the x, the square, plus 3x is equals to 0. You will notice that our dependent variable here, the order or the degree of this differential equation is 1. So which means, and this can also be written as y this so this is an example of a linear differential equation because the degree of our dependent variable is 1. Also, another example, let's say we have the cube y, the s cube, plus 3x, the square y, the x, plus 4 the y, the x is equals to 0. This is also another example of a linear differential equation. Why? Because the degree here is 1. And this also can be written as three x y double prime plus 4 y prime is equals to 0. So by implication, this is a linear differential equation. So let me give you an example of nonlinear. If you have something like this, let's say you have the y, the x, plus 2xy squared is equals to 0. This is nonlinear. It is nonlinear because it is of power 2. So for it to be nonlinear, for it to be linear, this must be of a single power. So this is where we are going to stop. In the next video, I'll be showing you some methods of that we can actually be used, that we can use to solve differential equations. There are so many methods that we'll be discussing as far as this topic is concerned. So watch out for the next video, and don't forget to click on the subscribe button and do well to also turn on your notification bell. See you in the next class. Thank you.